Once it is done, give me an alert. I'll start speaking.
All done, sir. Please start.
Okay. So a very good evening to all present in the meeting. This is the first meeting of the NACDeC-VIII competition. And in today's meeting, we are basically going to provide you an overview of the NACDeC-VIII competition. Yes, Norman, you have raised your hand. Please go ahead.
Sir, streaming is not started on YouTube.
I think there is a delay of about 30 seconds.
Okay, got it.
Between the... Yeah, okay. So let me start with an outline of today's meeting. We will spend a few minutes talking about NACDeC. Most of you who have registered for NACDeC already are aware about NACDeC. But still, for completeness, we would like to talk a little bit about NACDeC. I will also talk a little bit about what exactly is aircraft conceptual design, because many people have a major confusion about this particular area. We will then move to NACDeC-VIII, the SUCAV problems. Then I am going to introduce you to the organizing team who are all present in this meeting. About NACDeC. So NACDeC was started in 2017 when during discussion with various aerospace companies in the country, we realized that the companies say that we want to hire aerospace engineers or we want to hire engineers for aerospace design activities, but they were not very happy with the level of knowledge and experience about aircraft design available in the various campuses. So our primary aim is to encourage and nurture aerospace conceptual design activities. And this we would like to achieve along with an interaction with industry experts. We are aiming to conduct at least one webinar like this every month. And you all know that there is a dedicated WhatsApp group and email account, which can be also used by you to discuss your queries and tell us about any issues that you are facing. Here, I would like to very clearly mention that we will completely ignore any message that comes directly on our WhatsApp number, both me and my teammates, or our direct email. You are not supposed to send direct messages, SMSs, phone calls to us. We all have our own commitments and jobs. So therefore, we will be able to work on NACDeC related activities only when time permits. For that, we have a dedicated WhatsApp group and email account. Only use that account and that email address to reach out to us. And be patient. You will not get the answers immediately, but I promise you, we will definitely respond with a reasonable period of time. Our aim is to give you a first-hand feel of how an aerospace system is designed. And we want you to not just do a theory, but also experience a design cycle right from conception to conceiving the design to doing the design calculations. All of you who are in the meeting, kindly mute your mics. And Pranav, being the host, you can manually mute them in case they don't cooperate. The bottom line is that we would like the engineering students in the country to be industry ready so that they can be employed by the aerospace industry, which is really a very booming industry, and it will further boom a lot going by all the projections that we hear about the aerospace sector. So I start with a few slides on introduction to aircraft conceptual design. These are a part of the course which is offered under the NPTEL. So I have just borrowed some slides from there. The important questions we need to address is exactly what is conceptual design? How do we start this process? And where do we stop the process? What is enough in aircraft conceptual design? So let us look at the evolution. Generally speaking, people start their aircraft design with working on remote control planes or designing at small aircraft, and then they proceed to much more complicated systems. Now, this is actually the full field of aircraft design. This is not aircraft conceptual design. This is full field of aircraft design. Okay. So we are not expecting you to do all these things. So if you look at the big picture, in aircraft design, we try to arrive at a layout and configuration that meets two requirements. First, it meets the requirements and specifications which the customer has given. And parallelly, there are certain safety requirements or requirements for uniformity, which are called as the airworthiness requirements. And the next important aspect, which many people ignore, is that a good aircraft design is the one that is less expensive and easy to produce in large quantities. Because aircraft design is not about making one aircraft or two aircraft, it's about making a large number of aircraft, repeatability. Okay. So this is what is aircraft design in general. Okay. Now, there are two things, customer specifications and airworthiness requirements. The customer specifications are the ones that come to you from the customer. Now, in our competition, we have already given you a problem statement. In the problem statement, there are some requirements. Those can be considered as the customer specifications. They normally come to us from the market based on what is already available. And also sometimes the requirements are driven by what the user needs. We also look at the forecast of the economic situation. This is more applicable for transport aircraft. And many things in aircraft design are demanded because of the technological developments that take place. Because technology has evolved, therefore people will demand certain things in the requirements, which were probably not there in the previous designs. The requirements which come from airworthiness, they are based on previous experience. They are there to ensure safety and also uniformity. So these are some things which are not specified by the user. They have to be taken into care by you directly by looking at the relevant airworthiness requirements or specifications. Okay. Now, aircraft design takes place in several phases, and generally it happens sequentially. The first phase is the method, which is the conceptual design. Here, the design team is interested in establishing the feasibility of a concept and to identify the requirements that drive the design so that they can go back to the customer and say, hey, because of this one requirement, the aircraft is becoming very heavy or very large in size. Would you like to reconsider your requirements? This is back and forth between the customer. This will happen with you and us also because we are right now the customers for you. So while doing the calculations or while doing the initial work, you will come across some roadblocks and then you will come back to us and say, is that requirement really important or can it be relaxed because something is getting driven because of that and we might reconsider it. You have to carry out initial sizing and arrive at the layout. I'll explain to you very briefly what is meant by initial sizing. And important thing is, in conceptual design itself, we are supposed to estimate the masses of various components, the performance of the assembled aircraft, and also cost. But in our analysis, in our current competition, we are not really going to bother too much about detailed cost estimation, although it will be nice if you can do it. The conceptual design phase is almost arbitrarily stopped when you decide that you have done enough work and the concept is ready. Then you start looking at numbers. And that phase is called as the preliminary design phase, where you start by freezing the configuration, no more major changes. Now you start looking at each aspect of the design, each sub-assembly, each major assembly, and look at the practicality of that. You develop the concepts which are used for the structural sizing, structural analysis, and mechanical systems. And you develop analytical and test base by doing a lot of testing. And then finally, once the preliminary design is over, you go to the detailed nuts and bolts where each component is designed. We develop the tooling for fabrication. We test all the items and then finalize the weight and performance estimates which are obtained earlier. Now, my question to all of you is, what is expected in NACDeC-VIII? So you can unmute yourself and just speak. Which of the phases, how many phases are expected to be covered in NACDeC-VIII by you in this competition? The floor is open
Conceptual
for any team.
I guess
Sorry.
conceptual and preliminary.
Okay, conceptual and preliminary. Okay, anybody else?
I also believe first.
Conceptual and preliminary. That is what you believe.
Yes, sir.
Okay, so all of you are wrong. What we require is only conceptual design. Okay, we do not expect you to do the work of preliminary design. We only expect you to do conceptual design, because it will be very difficult for you to do preliminary design. It is not an easy thing. It is actually to be done by an experienced design house and not by students who are learning the process. So remember, you are only going to look at the conceptual design. That is why the competition is called as National Aircraft Conceptual Design Competition. Pranav, please take care of the people who are not muting themselves. So you will work only in conceptual design domain. Going a little bit deeper on the phases or looking at it differently, the conceptual design phase is actually where you compare the various competing concepts, you establish whether the performance requirements will be met, and then you come up with the shape and the conceptual layout. That's it. So it constitutes only 1% of the entire design process. The next the next aspect is preliminary design, where you go for refined sizing, optimization, where you go for wind tunnel testing, and you go for modification. Now, this is not what you will be expected to do. I do not expect any student team to do wind tunnel testing as part of this exercise. Okay. If you do it, it is fine, but that will not fetch you any extra marks in the competition. It's up to you. And then the 90% of the work happens, which is boring, routine, standard work, where you go for making the drawings of each component, you do CAD of each component, you look at the detailed performance estimation, and then in this phase, only minor changes are permitted, and you look at the certification. So once again, you are only going to do 1% of the total exercise of developing this particular aircraft, and that is the conceptual exercise. Okay. Now, I would like to take a short break here and open the floor for any questions that you may have about what all I said so far. Okay. So the floor is open. There are 46 people in this meeting, out of which a few of them are our own volunteers. So the floor is open to anybody who would like to talk or ask any questions regarding the aircraft conceptual design. Don't go to the competition. Don't go to what is expected in the examination. All that we will discuss later. Right now, just ask me questions related to what I have shown you so far. Floor is open. Please go ahead. I'll put my camera also on. Please go ahead.
Hello, sir.
Yeah,
Hello,
I
sir.
think everybody mute themselves.
So, what are the parameters we can estimate while doing the calculations of conceptual designing?
Okay, that I will come in the next few slides. Okay. Ask me questions based on what I have shown so far. If something is not clear, if something is ambiguous. Otherwise,
Sir,
I will proceed with my presentation.
Sir, at the last part, we have discussed that we need to also finalize what the components are going to be in the system checks. So do we have to design all the internal components of the flight as well, or just the
No,
body design?
did I mention in the conceptual design that you have to design all the components? No, that is a part of detailed design, which you are not going to do.
Okay. Okay.
You are not expected to design each components internally. No.
So there's a statement written, carry out initial sizing and layout. So can you just brief a little about it, what should be the
Yes, yes, yes. That is the next slide.
parameters?
That is the next slide.
Okay, sir. Okay.
Okay, maybe I'll just go ahead because I don't think people have any questions related to what I've said so far. So I'll just go ahead and I will. 1 minute. Okay. Once again, I want a confirmation that it is visible to you.
Yes, sir, visible.
Yes, sir.
Okay. So this is a question raised by somebody. What is meant by initial sizing? Okay. So initial sizing basically means estimation of the design takeoff gross weight of the aircraft, normally called as W0. This is the weight of the aircraft when it is about to start the design mission profile. It is also called as the all-up weight of the aircraft. But all-up weight of the aircraft can be for various missions. The aircraft actually does a mission other than what is the design mission, but there is a design mission given to you in the problem statement. When the aircraft is designed to do the design mission profile, what is the weight before it starts? That is called as a design gross weight. And estimation of that number is called as initial sizing. In initial sizing, we do not go for any geometrical detail of the aircraft that much. Okay. Now, the mission profile, of course, is specified by the user, and that is already given to you in the problem statement. Additional requirements are given by the regulatory bodies. So you need to do some study about what are the requirements applicable to an aircraft in the military. Okay. And maybe we will invite a regulatory expert to talk to you about it in a webinar. It's a good idea to call an expert on requirements on certification to come forward. Now, what are the objectives? The objectives of initial sizing is primarily to identify which requirements given by the user are the main requirements which are driving the design, and also to get the first estimate of the size of the aircraft through W0. That is the main purpose of initial sizing. And for initial sizing, there are several procedures available in standard aircraft design textbooks, which I will show you very briefly. I will give you a list. Okay. The next aspect is configuration selection. So when you do configuration selection, basically for various important components of the aircraft, for example, the fuselage, for example, the wing, tailplanes, engines, landing gear, some of these may be absent. For example, you may design an aircraft with no vertical tail, in which case there will be no vertical tail, but there will be horizontal tail. You may also go for a complete tailless aircraft. But whatever components are there, you have to arrive at the conceptual shape. You have to look at the functional characteristics, and you have to arrive at the layout, which is the relative position. Is the wing mounted above the fuselage, in the middle of the fuselage, or below the fuselage? Is the tail mounted ahead like a canard or behind like a conventional aircraft? Or you're going for three-surface configuration where you have a canard, wing, and tail. Engines, are you going to have one engine, two engines? Some of these may be given by requirements. If not, you have to decide. And then where will you put them? In the nose, in the tail, above the aircraft, below the aircraft, landing gear, etc. So you need to arrive at this. Now, there are many driving factors. Okay, I don't want to list all of them. They are already mentioned here. But interestingly, these requirements are quite, differently accepted by various people. And therefore, there is a beauty of aircraft design that if you give the same problem statement to different aircraft design teams, you will get probably different suitable configurations. And hence, I always say that in aircraft conceptual design, there is no unique solution. The solution is driven by the design sensibilities and the preferences of the design team. So that is why there is a competition. Otherwise, all of you would have come with the same configuration. So that is the beauty of aircraft conceptual design, that more than one configuration may be equally suitable. And it is for the evaluating team or committee to decide which one is better than the other based on certain criteria. Now, when you do aircraft initial sizing, there are 6 parameters which Daniel Raymer has given, called as the big 6 parameters. These 6 parameters generally capture the essence of the aircraft. 4 of them are related to the wing of the aircraft, which is not in the order of importance. It could be wing aspect ratio, it could be wing sweep, wing taper ratio, and the wing thickness ratio. These are 4 important parameters which are wing related that kind of characterize the wing apart from the wing area, which is the number that you calculate after doing sizing. So once you have the wing area, by deciding these 4 parameters, you pretty much fix the aerodynamics and structural configuration of the aircraft. Then there are 2 parameters which are aircraft related to the whole aircraft. These are the wing loading or the W0 by S and thrust to weight ratio, or in case you are using a turboprop or a piston prop engine, it will be power to weight ratio. In your case, I don't think you can fly supersonic with the power plant, which is piston prop or turboprop. So in your case, it will be only thrust loading. The total thrust produced by the aircraft under sea level static conditions divided by the design gross weight. So these are the 6 parameters which Raymer says that if you arrive at the value of these 6 parameters, you have pretty much captured the important configurational related or design related parameters. There are many more, but these are the big 6 parameters. Okay. Now, why are we talking about these W by S and T by W? Okay. Can somebody answer this question? See, it's already answered there. It is important to know the value of W by S and T by W for any aircraft because they appear in many performance equations. For example, if you look at takeoff distance, sustained turn rate, range and endurance, and climb performance, both W by S and T by W play a role. You cannot decide the value of W by S arbitrarily unless you take care of a corresponding T by W to meet the requirement of these 4 parameters. Then there are some parameters, there are some performance parameters which depend only on wing loading, W by S. These are the stalling speed, the landing distance, the ceiling, and the instantaneous turn rate. And then there are some parameters which depend only on T by W. These are the climb gradient and the missed approach gradient. Now, some of you might say, what is meant by climb gradient? What is meant by missed approach gradient? What is meant by sustained turn rate? What is meant by ceiling? You have to read this and you have to study about it. And this is what is part of what we are going to examine when we conduct the design competency test. We would like you to know about these parameters and how they are estimated. In fact, you should be clear about these parameters. Now, one very important aspect or task in aircraft conceptual design is called as constraint analysis. So in constraint analysis, you look at all the requirements given by the user and all the constraints imposed by the users. And generally, you put them in the form of lines or curves on the graph between wing loading and thrust loading. So this is one example. In some textbooks, you will find that wing loading is on the y-axis and T by W is on the x-axis. But generally, what I have learned is that T by W is on the y-axis and W by S is on the x-axis. Each of these lines, the green lines, the black lines, they represent certain constraint and some area above or below that or on the left or right of that is feasible. So in this case, all these lines together represent a solution space. So now your solution can be anywhere in that space and you can choose any point in that space which will meet all requirements. Okay, so this is called as constraint analysis. This is one very important thing that you will have to do in your conceptual design report. Without constraint analysis chart, we are going to summarily dismiss your calculations because we are very clear that You have to arrive at solution space and then choose the values of these two parameters that best meet the requirement. Okay. So here is a typical constraint diagram which was drawn based on certain exercise done by somebody. Don't worry about the details. Just see that you will get graphs like this, and then you pick up. In this case, the design point has been picked up as the bottom right junction. So the area on the left of the vertical lines is feasible. The area on the right is infeasible. The area below these curves is feasible. The area above these lines is feasible. So you find that this is the design point that the team has selected for their design. So you will do a similar thing. You will plot various constraints. Notice three lines, vertical lines, are the ones which depend only on W by S. The two horizontal lines, the missed approach gradient and the second stage climb gradient, they are only dependent upon T by W, so they're horizontal lines. And then there are some lines which are curves and some are which are linear, which are combination of both the parameters. Okay. Okay, now I think this is a time when we can stop and we can take any questions regarding aircraft conceptual design. Because now we will move to NACDeC-VIII and what we expect from you. So any questions anybody has regarding aircraft conceptual design and what is to be done, about initial sizing, about constraint analysis? The floor is open. Just start speaking.
So what are the softwares are we open to which we can use?
Okay. You are asking questions which are there in the next few slides. I'm sorry to say that, but just wait. I have made a list of softwares. My humble request to you is ask questions up to based on whatever I have shown so far.
Sir, do constraints also include material constraints?
Not really. No, not in this diagram. In this diagram, we don't have anything to do with structures. Material constraints are incorporated when you do the structural calculations. There you decide the thicknesses and the materials based on the stresses that are expected. But that doesn't come in the constraint diagram.
Okay, sir.
The constraint diagram is basically driven by the performance requirements of the aircraft.
Okay, so for hydraulic systems and the layout of fuel tanks, are we supposed to go deeper or just brush it off?
I just could not understand what you are saying. So can you repeat your question, please?
Okay, I'm talking about hydraulic systems. Are we supposed to design hydraulic systems in the layout of fuel tanks, or that's not part of the committee?
That activity does not come under conceptual design. As I've already told you, those things come under preliminary design and detailed design. You are not supposed to design fuel systems or control systems or hydraulic systems. No.
Okay.
I have a little question. There's a mission requirement in which we are being asked to have a payload capacity of 1,000 kilograms. So, I don't understand how we will be asked to integrate it with the designs. Is this the requirement that is combat related, that is ammunition or something? So, just a little confusion about it. Can you clear?
Yeah, you are supposed to carry an equipment or armament which weighs 1,000 kg. That's it. So in the initial conceptual design, you are not bothered about whether it is a missile or a rocket right now. Right now, you just have to ensure that your aircraft can carry 1,000 kg for the mission.
Okay, sir. Okay.
Later on, that 1,000 kg will be told to you, okay, there are 4 missiles, each weighing 250 kg. So therefore, you have to, that comes under preliminary design. Right now, you are bothered only about payload capacity.
Okay,
Sir,
sir.
can
Thank
you
you.
brief me about design point once again, sir? I did not get it very much clearly.
See, I'll go to the previous slide. I think that will be better. If you look at look at the typical constraint diagram. As you can see, the solution space, basically the feasible space, is on the left or above these lines. So you can see there is one vertical line. So the area on the left is feasible, on the right is infeasible. Similarly, you see these green lines, you see the black lines, the area above these lines is feasible. So when you draw these lines based on the performance values, see, there are equations available which relate thrust to weight ratio and wing loading for various performance requirements. You can numerically calculate the value, you can numerically draw these lines. So you can see there is a solution space. Now, any point in the solution space can be picked up as a feasible point, because any point, any combination of W by S and T by W that falls in the solution space will meet all the requirements. Is it clear?
Yes, sir. Yes, sir.
Now the question is, which point do you pick up? So if you look at this particular diagram, you have many options. You can pick up this top left point where I'm putting my mouse. Can you see it?
Yes, sir. It's visible.
Yes, sir.
You can also pick, you can pick this point. You can pick this point. You can pick this point. You can pick this point, or anywhere in between. So generally speaking, the designers normally try to pick up the lowest value of thrust to weight ratio and the highest value of wing loading that meets all requirements. So if I was a designer, I would pick this point, because this point corresponds to the lowest thrust to weight ratio, right? Okay, this point has got a higher value of wing loading, but the thrust to weight ratio is also high. And when you have high thrust to weight ratio, you have a bigger engine. Normally, it consumes more power, so more fuel. So therefore, I would prefer this point. I would give more weightage to thrust to weight ratio than to the wing loading. So now any point in this space is feasible. I will choose this point or maybe this point. Somebody might say, okay, let's take a compromise solution. Let us choose this point, which is neither here nor here, but in between. Okay. So the selection of design point is left to the design team and their own logic and their own justification. Now, I want to ask you one question. If you notice, the solution space has been drawn slightly above all the constraint lines. Okay. Can you see there is a gap between the constraint lines and the solution space? So can someone tell me why is there a gap like this? Why not choose exactly this point, which meets the vertical line constraint and the black line constraint, this one? Why not here? Why is there this gap here?
So it does not reach or exceed the limits of the performance which is calculated.
No, but
Sir,
if I
because
choose
the values we have been calculating over this lines are not actually ideal. That are actually ideal, and we can't either reach those particular values. Maybe that's why
no,
there's a
that
gap.
is not true. That is not true. We can reach those values. See, once I draw these lines, they are based on the requirements specified. So technically speaking, I can pick up this point, which is the intersection of the vertical line and the black line, because that will be a higher wing loading than this point and little bit lower thrust to weight ratio than this point. But I will not pick this point. I will pick this point, which is little bit on the left and above. So why is that
Sir,
so?
is it because we want to maintain some factor of safety? Because usually we do that while designing.
Yeah. So don't use the word factor of safety. You should say margin of performance. See, the performance requirements given by the user, they can creep slightly. And in doing the calculations, you may make some assumptions which may not exactly be valid. So the aim is to keep some margin for growth. Also, in real life, when you design the aircraft, so what will happen is when you pick the design point, you will pick W by S and T by W. Now, W is available to you from initial sizing. So that means you will get the T value and the S value. With that, you will design the aircraft. Now, suppose there is a slight increase in the actual weight of the aircraft when you practically make it, then it will fall below the requirement. So this is kept for some margin. So a little bit of margin is kept. You choose a wing loading slightly less than what max you can choose. You choose a thrust loading slightly higher than what you can choose to keep a margin. That is why it is there. Okay, so not factor of safety. Factor of safety is used basically only when you design the structure or any other equipment. The correct word here will be the margin in performance. Okay, very good. I'm glad that you are able to think like a designer, right? So now is it clear to everybody how you design, how do we use the constraint chart? So now I'll show you the actual chart for one of the calculations that we have done. In this case, the feasible region happens to be on the right of this line, on the left of this line, above this line. So they have not picked the intersection point, they have picked slightly above 0.4 and 800. That is the design point. Okay, any more questions?
Sir, do we have to submit? So do we have to submit a single configuration design or multiple configurations of the design?
No, you can submit in the initial reports, you can submit multiple configurations. For example, when you have a midterm report, there you can say we are looking at 3 configurations parallelly and we are not able to decide right now which is the best. But it will be among these 3 or a combination of these 3 in the final. In the final report, we expect only one solution. Angiras Baukar, you raised your hand. Would you like to speak?
Yes, sir. Should we have to consider like manufacturing point in conceptual design, like when we assemble the plane together, then might some components will be interfering with each other. Then what we have to consider this in conceptual design or not?
No, no. Because in conceptual design, you do not reach to the level of each component. So you don't know who is interfering. You don't go to that detail. Only when you go to the detail of components, you can talk of interference, right? So when you make the whole aircraft in CATIA and when you start putting each component, then only you start seeing the interferences. But we don't expect you to do all that in conceptual design. So therefore, do not go to component level work. Go only to the major assembly and subassembly work like wing, fuselage, tail, engines, nacelles, cockpit, maybe the shape of the aircraft. That is all we are expecting from you. Inside details, we don't expect you to really do too much. Okay. So on the chat, there are 2 points raised. Mark number and requirement. Please read that in the document. That is already there in the design document. Just give me a minute. Yeah, okay, let's go ahead. Any other questions or we'll go ahead with our further discussion? Any query regarding aircraft conceptual design? If not, then we will go ahead. Okay, and feel free to interrupt me in case you have a doubt. Now we come to NACDeC-VIII, which is, as you all know, focusing on the supersonic unmanned combat aerial vehicle or SUCAV. To give you an idea about previous NACDeCs, just a list of all the problem statements that we have given. But this year, our statement has come from the use of supersonic unmanned combat aerial vehicle. And one change we have done from the announcement is that we have removed the deadline for registration because we are going to conduct an examination. So, anybody who gives the examination is, eligible to register. So, technically speaking, if we do not hit the maximum number of 100, even up to 10th or 11th of January, we will continue the registration. Okay. Right. Now I'll go ahead and talk to you a little bit about the new initiatives of NACDeC-VIII, which are not there in the previous NACDeCs. So earlier, we used to put a restriction that, so when we began NACDeC, we had put a condition that only for aerospace engineering students. But then a lot of people showed interest, and then even the tasks given were also requiring some mechanical and electrical work. So we allowed, and we said, okay, minimum 2 should be from aerospace background. But that also we have removed this year. So the whole team can consist of all non-aerospace engineers. We have no problem. And also, many teams were registering because of their pressure from their HODs and their directors and the principals, but they were not interested in the competition. So they would just register and waste our time and effort and not submit their reports, not take part in the discussion. So this year, we have put a registration fees of rupees 2,000 per team, just to restrict the number of frivolous teams. You will be surprised to know in the past there have been cases when 45 teams have registered and 12 teams have not even bothered to give any report right from the beginning, because later on they confessed that we are not interested, we were forced to register. So we have removed that. Also, as all of you know, we have introduced an examination called as a design competency examination, about which I will talk in more detail very soon. So only those teams who clear this examination will be allowed to continue further ahead. Okay. Then we have this time a formal participation from a company called Autodesk, and they have agreed to come forward. So first of all, they are going to give a free, fully functional license of the software Fusion 360, and I think a few other softwares that they are offering. It will be free of cost to all the NACDeC-VIII participants. They have agreed to conduct 3 online training programs, preliminary, intermediate, and advanced. These exams will be, these online sessions will be conducted after 12th of January, when the teams have been finally shortlisted. And it will be conducted by the expert from Autodesk online. Then they have also agreed to give t-shirts and some goodies for all the people who reach the final round. As you know, there are various stages in NACDeC. So the last stage consists of shortlisting of 5 teams. Each team can have maximum 5 members and, of course, a mentor. So, these teams will be shortlisted. So there'll be finally 3 teams. So the members of those 3 teams who are called for the final round, they will be given t-shirts and goodies by Autodesk. And then they have promised a prize money of 4 lakh rupees total, which will be shared among the top 3 teams. Okay. So these are the 4 ways in which Autodesk is going to officially partner. In today's meeting, I was expecting the Autodesk India chief to come and join us, but unfortunately, he had some other commitments in the office. So he has sent his regrets. Okay. But I'm sure in one of the next meetings, he will be there in the meeting. Okay. Any doubts anybody has regarding these new initiatives?
No, sir.
Okay, so let's go ahead and look at what are the objectives of this particular NACDeC-VIII competition. We are looking at developing a vehicle for neutralizing the threats, and also we want to use it for quick intelligence gathering for surveillance activities. That is the broad objective of NACDeC-VIII vehicle. The mission profile is as shown here. Now, this is something that has been arrived at in association with the user agency, correct? Now, you don't have to ask me why 14 kilometers altitude, why 1.5 kilometers strike distance, why payload mass 1,000 or more. These numbers are given to you right now. If you do some initial calculations and if you come up with some very horrendously looking designs because of some requirement, we can have a negotiation session where we can say, oh, I'm sorry, because of endurance 2 hours or more and the range 1,000 kilometers or more, the vehicle is becoming too large. Then we can discuss and we can come to an agreement. And that is the main benefit of doing aircraft conceptual design. That means to identify the requirements that drive the design. Right now, these requirements are final and you don't really have to counter and say why. Okay, just use them as the requirement from the customer. And then this is the schedule. But first of all, I want to ask, do you have any query regarding these requirements? Any doubts regarding the requirements?
Sir, one doubt. Here, endurance is from takeoff to land, or only the cruise and loiter is time is 2 hours?
only the cruise and loiter time is 2 hours, not from takeoff and land. Endurance basically means flight over the station. Okay, so you can notice in the mission profile, there is a mission where you take off, you go to high altitude, you go for a long distance cruise, then you come down and at 1.5 kilometer altitude, you do a strike mission. After that, you go and do a loiter. So that particular phase, that phase should be 2 hours, the loiter phase. The second level flight phase is loiter phase. It's called as cruise and loiter. That is a phase where it should be more than 2 hours, not the entire mission.
So can you
Okay.
say something more about this strike at 1.5 kilometer? Like, what does it actually mean?
The payload that you are carrying is going to be released at a 1.5 kilometer altitude above the mean sea level, and you will be required to fly supersonic during this mission, during the cruise mission.
So the
Okay,
strike
now
will be
at
at
what
subsonic
Mach
speed.
number?
To have a like supersonic speed during the strike because it will be much difficult.
No. I never said that. I said that you are expected to fly supersonic during the cruise, during the first cruise segment. The strike will not happen at supersonic Mach numbers. We will specify to you at what is the requirement at that point. See, these requirements will be elaborated. This is the first cut requirement. They will be elaborated. So during strike, which happens at 1.5 kilometer, you are not supposed to fly supersonic.
And
They will
so,
tell you what is expected.
what is the like expectation or requirement of the maximum Mach? Like, what should be the maximum supersonic speed we should be having? Like, is it Mach 2, Mach 1.6, or Mach 3, or whatever? Like, being
Mach
asked.
1.7.
Mach 1.7. Okay, sir. Thank you.
That will be clarified. See, we are expecting the final number. It will be of the order of Mach 1.7. That is what we have been told. We have not given it right now because that number is still being worked out.
Just I would like to add something to that. In the problem statement, we have also given an optimizing factor of ml by d. So as long as we're able to maximize it, you have a choice of selecting your Mach number. That is what I
But
have.
there will be a certain
Yes,
value of Mach number.
lower bound will be
Minimum Mach
specified.
number. Minimum
Yes.
Mach number will be given. You can go for higher Mach than that. As he said rightly, you have to optimize ml by d. But there will be some minimum m. That minimum m I thought was around 1.7. We will inform you in detail.
Sir, what is the meaning of this last line, change in static margin from subsonic to supersonic?
Do you understand the meaning of static margin?
No, sir.
So you have to read about it first. What is static margin? And we know that in supersonic flight, when the aircraft goes from subsonic to supersonic, there is a change in the CG in the location of the aerodynamic center, because of which there is a change in the value of static margin, which is the parameter about which we have to read. And we will ask you in the competency examination your understanding of static margin. So there will be a change in static margin, and we don't want that change to be more than 10%. That is our requirement. So you have to design the aircraft in such a way that when you go from subsonic to supersonic, because of the change in the aerodynamic center location, the static margin should not change beyond 10%.
Okay, sir, got it.
Okay. Any other question regarding the mission profile or requirements?
Not yet, sir.
Yeah. So all operations are expected to be conducted under the Indian Reference Atmosphere, IRA. So you need to study what is meant by IRA. It is different from ISA, which is the International Standard Atmosphere. There is something called as IRA, Indian Reference Atmosphere. So there are documents available online where you can search about IRA and the IRA variation of density, temperature, and pressure with the altitude. Remember, when you do the design calculations or the performance calculations, the atmosphere you have to assume is IRA. Okay, let's go ahead. Now we look at the proposed schedule. Remember, it is proposed. It is based on our own initial assessment. This schedule can be tweaked slightly up and down depending on the majority of the teams. Okay. So I'll go line by line. So this first line is redundant now because we have removed this deadline. This deadline happens to be something like 11th January, or whenever we have 100 teams, or whenever we have, or up to 11th January, whichever happens earlier. Okay. On 12th Jan, there will be an examination about which I will speak to you. Based on your examination, we are going to shortlist the teams for stage 1. And remember, there might be a need for conducting a small viva-voce examination after the competency examination. If we have a doubt regarding some team, then we might reconfirm our doubts by conducting an online viva. So we have kept 3 days for that. So based on that, by mid-January, we will shortlist the teams for stage 1. This number, how many teams we will shortlist, is open. Generally, we don't want to have more than about 40 teams or 35 teams at this particular stage. Okay. So then you will be given 2 months' time to come up with the midterm report. In the midterm report, you will tell us what you have done in these 2 months and also the months before that. What is your current thinking? Do you have 2, 3, 4 configurations which are your candidates, which you will finalize? And what is your plan of action for the remaining period? Okay, because the submission will happen by almost 25th of June. So how are you planning to do the remaining part? We'll ask you. That will be the midterm report. We will take around 10 days to go through these reports. We have a panel of examiners, and then we will announce which are the teams which have been shortlisted for the second round. So normally we would like to have something like 15 teams or and in stage 2 approximately. There's no fixed number, but around that number. These 15 teams will then get around 3 months more, April, May, June. 3 months you will get to do the final reports of. Then we are going to go through the reports, shortlist some teams, and then we will conduct a viva. And then in the viva, we give feedback to various teams. And then we give you nearly 20 days time to modify your report. And then based on the modified report, we will shortlist the teams for the last stage, which is stage number 3. And then there is a long break because that is a summer vacation. And then, by mid-August, normally we have the final round. So are there any questions or any doubts regarding the schedule?
No, sir.
Sir, final
No,
round
sir.
only presentation, or is it another set of reports modification?
No. After you submit the modified report on 20th of July, there is no report submission. There is only a presentation.
So, what will we be doing in the final round? Like, is it only a presentation of the whole thing we have done?
Correct. So in the final round, there will be a panel of examiners. Generally, we have 5 or 6 examiners. They will listen to, so you will be given about 15 minutes to present your entire design work. And then they will question you or examine you for about 15 minutes. So we normally keep half an hour per team for presentation as well as evaluation. And based on the marks given to you in the report and also the marks given to you in the viva, in the final presentation, we shortlist the teams as first, second, third out of 5. Because on 25th July, we will shortlist only 5 teams for stage 3. Out of these 5 teams in stage 3, in the final stage, out of these 5, you will get first, second, third as the outcome. So the marks scored by you in the report and in the viva together constitute the evaluation. Okay, any more doubts?
No,
Sir,
sir.
can you tell a bit more about the competency exam, like the format of it?
Okay, right. So of course, there is a website which is giving all the details. Let me first list down what tasks are we expecting you to do, and then I'll come to the examination. So in this whole entire exercise, this is what we expect you to do. We would expect you to do a survey of existing aircraft so that you are familiar with what aircraft are there in the market already or under development. We want you to do initial sizing. We want you to select the configuration. We want to do some basic aerodynamic analysis of the whole aircraft, not individual components. Then we want you to do constraint analysis, as I mentioned to you. Choose a power plant and size the power plant. Structural layout and sizing, very basic. Then we want to do performance estimation to confirm that all the performances that we expect are met. And then there are something called as LETs in aircraft design: reliability, survivability, susceptibility. So we would like you to look at what are the features you are providing in the aircraft to improve the various LETs, like maintainability, not mentioned here. Maintainability, reliability, survivability, receptivity, these are all LETs, which a good military aircraft, even transport aircraft, is supposed to have. But things like survivability and susceptibility are not applicable for transport aircraft. Okay. And then very important is you have arrived at some parameters. What is the sensitivity of the aircraft to the values of these parameters? Those studies also have to be included. So in your final report, we expect you to cover all these things. We will give you elaborate instructions later also. This is just to give you an idea right now of the feel of what is expected from you. Okay. Any questions anybody has about the task to be done?
So in the power plant selection, are we required to choose some particular type of engine, like a turbojet, a turbo ramjet, or turboprop engine? Is there any specifications or like preferences by NACDeC?
See, if you talk about turboprop engine for this mission, it is clear that you don't understand the requirements. Okay, but I have no problem. If you choose turboprop and if you justify its use for a supersonic aircraft, I have no problem, but practically it won't happen. So the power plant is going to be mainly a turbojet. Okay. Now, ramjet you can use, but ramjet, it requires to achieve a particular Mach number before it can start. So you will have to augment it with a turbojet. It's possible. So that is what we want you to tell us. Are you going to use a simple turbojet, or are you using it with a bypass ratio? Are you using a combination of turbojet and ramjet? That is up to you. That is what we mean by power plant selection. Yes, Shashank, please go ahead.
Sir, are there any material constraints during the design process that we have to consider?
There are material constraints which you will yourself decide. When we talk about the structural layout and sizing, we expect you to tell us what kind of material is going to be used for designing, for fabricating the wing, fuselage, tail. Are you going to go for composites? Are you going to go for metal? Are you going to go for mixed? Are you going to go for carbon fiber, glass fiber, boron fiber? What kind of material will you use? Are you using titanium? All that will be part of structural layout and sizing.
Got it, sir. Thank you.
But again, we are not looking at material at component level material work. We are looking at general work, because we want you to estimate the weight of the aircraft, for which you need to know which material is used how much.
Yeah, okay, sir.
All right. Any other questions regarding the task to be done? Okay. So moving ahead, we can again come back. Somebody asked me about what softwares to use. So there are many softwares which are available. There is XFLR5 and XFoil, and there is a new version of that available for basic aerodynamic analysis. Then you can use MATLAB, Excel for sizing and performance calculations, or you might write a code in Python. You can use CATIA, SolidWorks, OpenVSP, Fusion 360 for CAD model creation if you want to make a model of the aircraft. You can use ANSYS, SimScale, CFD++, OpenFOAM for CFD analysis. We prefer you to use LaTeX for documentation, but you can also work in MS Word. Only problem is that you have to use licensed versions of these softwares. We will not be responsible for any damages, because remember, this competition is very popular, and all software companies, they also, right now, if you notice, Autodesk is a part of the competition. So if the software companies detect that you have used their software, and if they come to know that you don't have a license, they are going to come on you very heavily. So you are requested to use only licensed version of softwares. And therefore, I prefer if people use open source. For example, instead of using CATIA, SolidWorks, I would suggest you can use OpenVSP, or you can use Fusion 360 because it is being given to you by Autodesk. Similarly, if you have a licensed version of MATLAB or Excel from your college, great. Otherwise, there are open source softwares like Python available. For basic aerodynamic analysis, also there are open source softwares available. Similarly, for CFD, we have OpenFOAM, and LaTeX also is an open source software. So we encourage and recommend open source softwares. In fact, instead of MATLAB, there is something called as Scilab, which is an open source equivalent of MATLAB. Some people, they use something called as Simulink. There is an open source version called as XCOS. So there is a free and open software for engineering, FOSSEE. You can go there and you can study and download these free open source softwares. We recommend if you use them. But we have no problem if your college has subscribed to CFD++ and they have a license. If you use it, we have no problem. But we have to be very careful. It has to be a legal version. It cannot be a crack version or a copy version. Okay? Any questions anybody has?
Sir, apart from these softwares, we are free to use any other softwares, right? We have,
Yes.
if
Can
we
you
have
name a
license
few?
for it.
Can you name a few of them which I have missed out?
Like we have Flow 5.
Yeah, you can use.
Yeah.
As long as you have licensed
Yes,
version of
correct,
the
sir.
software, you can use it. We have no problem.
Thank you,
These
sir.
are the ones that are normally used. I don't know about Flow 5, so that's why I have not mentioned it. I'm very happy and curious to know which are the other softwares which we missed out, because we will include them in the list.
Yeah, there are many like open source toolbox also for UAV design. So those things also we are free to use, right?
Yeah, no problem. You are welcome.
Okay, sir.
Okay, so moving ahead, we issue certificates to the students who take part in NACDeC. The top three are the prizes that we give to the team members, first, second, third prize. There is no separate certificate for the team leader because we believe that the team is totally together. So last year there was a request by somebody saying, I am the team leader, I have done extra work, give me a certificate. But we said no. Each team has all members are equal as far as we are concerned. So we give only first, second, third prize. Then we give a certificate of participation to all the teams who are shortlisted in the final round, all the 15 teams who are shortlisted in the final round. Then we also give a certificate of appreciation to the mentors. Okay. So this is what we have been doing. Right. Now I want to talk a little bit about the design competency examination. So this examination will be conducted online. That is first thing. In which mode we will do it? Will it be MS Teams? Will it be Zoom? I don't know right now. We will decide and let you know later. There will be one dedicated webinar in December about the examination and the examination procedure. So that time we can discuss more about the examination. Basically, you have to start getting familiar with aircraft conceptual design. So for that, there are certain textbooks available. There is a textbook by Daniel Raymer. There is a textbook by Mohammad Sadare. There are NPTEL courses. Okay, for design of supersonic aircraft, there are special dedicated texts available which highlight the procedures for conceptual design of high-speed aircraft. But some books are a bit difficult to follow. For example, there is a book by Professor Egbert Torenvig which is a bit difficult to follow. Similarly, there is a very good book called as Design for Combat. That's also a very good book. So you are welcome to use textbooks which are available online, like a book by Professor John Fielding on aircraft design, but focus more on the books that talk about the military aircraft design. There is a book by Jenkinson, Simpkin, and Rhodes, but that is only to talk about civil aircraft. So don't worry about that. That is not relevant to you. There is a very good book by Nikolai and Carrickner, One volume of that is dedicated to military aircraft, the first one. So I would recommend these books. Plus, there are 2 courses on NPTEL. In fact, there are 3 courses. One was taken by one of my old professors called Professor Tulapurkara from IIT Madras. But among the new people, there is one course by Professor A.K. Ghosh of IIT Kanpur. And then there is also a course run by me on NPTEL, which has just been completed on aircraft conceptual design or introduction to aircraft design. You can look at the content available in these courses, in these textbooks, and please use the WhatsApp group and the email address to ask your queries. Okay, the moment we get queries, we realize that you are studying and preparing. It gives us a flavor of what you are doing and how you are preparing. And if we feel that you are on the wrong track or looking at the wrong material, we will alert you. We will guide you. Suppose you have some doubt regarding one specific aspect, we will alert you. We'll also conduct one webinar next month. As I mentioned to you, we promise to conduct one webinar every month. That is our endeavor. We don't know how much we can do it, but we plan to do one webinar minimum. Harish Karthik has raised the hand. So Harish, please go ahead.
Sir, is it good to use J.D. Anderson's book, The Introduction to Aerospace or Aircraft Design?
It's a very basic book. Okay, there is a book by Anderson on design. That book might be useful to you. Okay. But the book on the basic book by Anderson may be too basic for you to really get any great information regarding the design of the aircraft. But there is a book by Anderson on design. That's a good one, and you can use that. However, it does not contain great details of military aircraft design. There is actually a book by 3 authors. I'm forgetting the names. That's a very good book for design of military aircraft because it runs a case of F-16. It runs a case of F-16 in the whole book. So that will be very useful because that is a military aircraft.
So is that the
we will,
Roxham book?
Yeah. Is that what?
I got a book by Roxham. Jan Roxham.
Roskam.
Yes, sir.
Jan Roskam has got a book with 8 volumes. It's very outdated, I would say, and also it is quite detailed, but it will have military and transport both together. So the book which I am referring to is a book called On Aircraft Design by 4 authors. I will fish out the details and show it to you. I will share with you the list. Okay, so if you give me 1 minute, I can even do it right now. But anyway, let's continue our discussion. So there are these resources available which you should be able to use. There are standard books available for aircraft design. Remember, the books which talk about UAV design, they may not be directly relevant to you because there are hardly any books on design of UAVs which talk about supersonic UAVs. See, this particular aircraft is actually more like a military aircraft with no pilot. Okay, so the design formulation, the calculations will be more related to aircraft design than to UAV design, unless you find a dedicated book on the design of UAVs of this class of aircraft. Then I don't know, but it's more near the aircraft than near the UAV. Although it's a UAV, but its features and its requirements are more towards a military aircraft, a fighter or a bomber aircraft, mostly fighter aircraft, because 1000 kg payload is a very small payload. So mostly that is the payload of fighter aircraft. So look at books that talk about design of fighter aircraft and adapt the formulation to your requirement. That is my suggestion to you. Rather than looking at books which talk about UAVs because they are mainly for small UAVs. So the formulation and the equations may not match exactly. Okay. Any other query regarding the books? Now I would like to introduce you to the team. So this particular competition has been patronized right from the beginning by Dr. Kota Harinarayana, who is, as you know, one of the brightest sparks in the Indian landscape for aircraft design. He is the one who is behind the Tejas aircraft. Okay, so he has been the chairman of the design division from 2017 till this year, and I have taken over from him very recently. I have been the convener of this competition for the last 7 years. Then we have two coordinators. One is Pranav Gupta, with whom you are always in touch. The other is Prachi. I think both of them are currently in the meeting. Am I right? Both of you, can you identify yourself, please? Pranav and Prachi, can you please
Yes, sir.
identify yourself?
I am in the meeting.
You are in the. What about Prachi?
I don't think she's here.
Maybe she's not able to join today. Then we have a team of 5 volunteers. Almost all of them, except Raghav Taide, have taken part in NACDeC earlier. So they are the ones who have already gone through this process. Yes, and Aman also has not taken part. So Akriti is the member of the winning team from last year. Namanuddin has taken part in several competitions. He's also the teaching assistant for many of my courses. Ajit Kumar Chetri, currently working in ADA in Bengaluru, has also taken part in the competition. So these are people who have taken part. Raghav Taide and Syed Aman Mansoor are the new volunteers who have joined our activities from this time onwards. So these are our volunteers. They will be handling various different aspects of the competition. Now we come to the end of today's webinar, and we would like to know if you have any queries which I have not covered. The floor is open now.
Sir,
Remember, details of the design examination will be given in the next webinar, because we are ourselves gearing up to prepare for that. What we know right now that it will be done online. It will be done on that particular date. And some people have asked in the group whether every member of the team has to be together. No, it's not required. You could be in different places, no problem. As long as you are there in the, as long as you are there in the meeting that we conduct, we are fine. Yes, Harish.
Is it possible for you to share the standardized books that you recommend to us?
Yeah, I should have done that in the PPT only. That's a mistake I've committed. I will add one slide. I will share that one slide on the group which contains the list of recommended books. I'll do that.
Yes, sir. Thank you, sir. Thank you so much.
Sir, I would
Anything
like to
else?
know. Yes, sir, I would love to know about like, should we consider the control systems of the aircraft or the avionics part? How much like
Yes,
do you expect
yes.
us?
Not too much in detail. Because you have to estimate the weight of avionics systems, so you need to know which instruments are on board, which systems are on board. That's all. We don't want you to really delve too much into avionic part. Okay, so yeah, it's a good idea to get an idea, to put a list of, okay, these are the equipments which we will be requiring for our aircraft, and hence this will be the weight of all the equipment on board for avionics purposes. But that's about it. Now, regarding control system, yes, your control system, basic sizing of control system will be needed again from the mass estimation point of view, and also to meet the requirement of minimum shift in the static margin. So there, for that, you will require to have some basic control system. So that's a detail. So towards the next few months, we will try to get an expert on the control system to come and talk to you on how to do it. I have somebody in mind, and I will request that person to come on board and talk to you about how to do the estimate of the control system for this aircraft. But the answer is yes, you will have to incorporate some work on control system.
So, sir, actually, we only need to do the identification of the avionics parts only, like only the computer to be used, not the algorithm we have to make for that.
No algorithm. No algorithm, no. Only the equipment that you will use. See, from the point of view of bookkeeping, from the point of view of sizing the cockpit, from the point of view of estimating the mass. That's all is the requirement.
Sir, one query from the problem statement. So the range is mentioned there. Sir, is it the combat range?
See, the aircraft is supposed to go somewhere, do the work, and then do the endurance on the way back. So what you can do is you can assume that the aircraft is heading back after doing the strike mission. It is not that it will go somewhere, go down, strike, and then travel further ahead. So that means the range is going to be the distance from the takeoff point to the point where it does the strike mission. That is the one-way range. Remaining is back. So that distance is the distance mentioned.
The same thing will be applicable for endurance because you said it is mostly returning cruise and loiter, returning one. But endurance is
Not
it?
mostly, not mostly, only.
So
Endurance of 2 hours is only after you do the mission and come back.
okay, sir.
Because in the first leg, you are only going somewhere. See, this aircraft is meant for quick response to some threat. So we want it to fly very quickly and go to some place, come down, do the strike mission. After that, we want it to just come back. And while coming back, we want it to not necessarily come back straight, but spend time in the air and then come back.
Okay, sir, it's clear.
Yeah, because what happens is many a times the aircraft may go to some place and not release the armament because you don't have the enemy below. So then with the armament, you want to circle and search where the enemy is. So you need 2 hours of endurance. Then you can again go down, dump your armament and come back. So that's why it is good to calculate the endurance for only the return leg.
So, can we like suppose that we have a propulsion system which is capable of doing vertical takeoff and landing?
There is no requirement for it. So if you put it, it is going to be a penalty. That penalty will not get you any brownie points. I would not recommend you to do that because you are given a takeoff distance length, right? Why are you not using it? Why are you giving features more than required? Because nothing comes free in aircraft design. If you are giving vertical takeoff and landing, that is your imagination. Customer does not want it. You are giving it. I'm sure you can make an aircraft lighter by not giving that requirement. So then why not do it? So don't try to bring your own requirements. Meet the requirements given by the user. Don't do anything extra.
Okay, sir.
We are not asking your suggestions on what should be the requirement. We are saying this is the requirement, design the aircraft. So you are not supposed to say, I'll make it vertical takeoff. Who asked you? We don't want vertical takeoff. Because we know that VTOL will be much heavier. In fact, you may be disqualified, saying that he has not designed the requirements. He has designed as per his own requirements. So be very careful. You have to design the aircraft to meet the requirements. Of course, you can
Okay,
say
sir.
vertical takeoff means takeoff distance is less than 1,000 meters, even zero is applicable, fine. But 100% I can tell you by my experience, it will be a heavier aircraft. And you will not win the competition because somebody else will make the aircraft lighter because of the takeoff distance. And we also will say, why is this person or why is this team going beyond the requirements? That means they don't appreciate the requirements. They want to bring their own requirements, not justified. Unless you show that there is no penalty because of the feature you have given. Then we'll say, okay, we don't want it. You are giving it. We don't want it. It's okay. As long as you meet our requirements, we are happy. Somebody else meets it better, we will give them the higher marks.
Sir, the altitude after that we have to reach while egressing, like it should be, it also should be the cruise and loiter altitude. It also should be the 14 kilometer, right?
Yeah, it's there in the mission profile. So follow
Yes,
this.
sir. Yeah. Okay. Thank you.
It's the same. You are supposed to cruise at 14 kilometers while going, and you are supposed to loiter and cruise back at 14 kilometers while coming back. And feel free to ask any questions regarding the mission profile. We will clarify it and we will update the document if needed so that any doubt you have is taken care. So, for example, payload mass more than 1,000 kg. Somebody might say, I will design for 10,000 kg. we have no problem. But if some other team makes it 1000 kg and they are better than yours, they will win the competition.
Sir, more little clarification, sir. Just like the endurance, that will be calculated after the strike. So will the supersonic cruise will be will be after the strike, or like the for the whole flight condition, like for before the strike
No,
also?
the supersonic cruise is expected to be only in the initial cruise.
So before the
See,
strike,
the
right?
return once the strike is completed, we do not expect it to, you know, I mean, it's a good idea for it to fly back, because if it can fly with the armament of 1000 kg supersonic, probably it can also fly back supersonic. So if there is no requirement to loiter, we would like it to come back at supersonic speed so that we can get away from the enemy. Enemy will not keep quiet. No? If you go some distance and bomb the enemy, they will not say welcome. They will retaliate to you. So if you fly back supersonic, it is good. But there may not be a need. So then we have to look at loiter. So this is the ability of the aircraft. So we should be able to loiter for 2 hours or more at 14-kilometer altitude after you drop the armament. But remember, the armament may not be dropped. We will not drop the armament unnecessarily. So when you do the loiter calculations, you have to assume that we went to 14-kilometer altitude, we went some distance, we went down, we spent some time looking for target. Nahi mila, there was no target. So we are going up and doing a loiter with the armament intact, because we may need to use it for whenever we find the enemy. So these kind of decisions you have to take, and maybe you can, take our approval when you do the calculations.
Got it, sir.
But that will happen after the design competency examination. So then there will be less number of people. So don't worry, we will have more such discussions.
Okay, thank you, sir.
Right now, you should only try to empower the team to do these calculations so that we are confident that you can handle the task. Not that, okay, we will do. No. By 12th of January, we want you to convince us that you can do the tasks. That is what the examination will determine. Do they have the competency to do this task? For example, we will ask you, how will you design the aircraft to cruise at 14 kilometer and travel 1000 kilometer? How will you calculate takeoff and landing distance of the aircraft? So we'll give you some aircraft parameter and we'll say calculate takeoff distance. Not necessarily the same numbers. We'll give you some other aircraft and we will say, for this aircraft, estimate the takeoff distance and tell us the value. So you have the time till 12th January to become competent enough to do aircraft conceptual design. So that after that, if you are shortlisted, you may not need any advice. You can just do the work. And of course, when you are stuck or when you have an issue, you are welcome to ask us. We are there to help you. See, we are there to not only give the problem to you, but also to nurture you. So when we say nurture, we mean we want to handhold you. So if you ask us questions in the group or in the email, and if we have a webinar, we discuss, we will try to help you out. But some help will be given to all groups together and some will be given individually to the individual team, whoever asks the question. So I would like to see more action on the WhatsApp group and on the email. The more queries you ask, the more points you discuss, that will be an indication that you are really working on it. All of that is going to be considered. Okay, if there is no more question, then I think we should stop the meeting. Already we have exceeded our time. It's already
Sir, I
almost
had a
8:30.
question.
Yeah.
Sir, according to the rules, only one team is allowed to participate from an institute, but there is there is another team from our institute who has registered, and my team was the first to register. But like their group leader and our group leader both have been added to the group. So,
We
like,
are going
what?
to write to your college saying that among these two teams, decide one team and send us, and we will remove the other team. Right now, we have not bothered to do any great cross check on which team from which college. Whoever has registered, we have helped it. But when we do our scrutiny, we are going to ask your college. We don't want to go by first come, first serve. If they don't reply, then we'll go first come, first serve. But if they say no, they might like to merge two teams. I don't know. So we are going to go because the the form has to be signed by the institution HOD or director. If two people have signed, the first thing we want to know, why is it so that they have signed? And then we'll say, okay, ho gaya, it is done. You please tell us which team is final. I have received this query from the HOD of one college, and I've told him this on phone that we are going to take only one team from each college. Since there are two teams from your college, kindly tell us which is the official team. The other team is going to be taken out. And if they have paid the
Sir,
money, we will reimburse the money also.
sir, actually, we talked to the HOD regarding this. He said that if it's required, then I will send a letter or email to the organizing team that the first team who registered shall be considered. So, shall we talk to him about this, or will you
Correct.
contact him?
No, you talk to him. It is better if you would to do this on your own.
All right, sir. Thank you.
Because what will happen is our action will be later and it will be too late. We might do this after the examination. So it is better that if you are not in the team, maybe the other team, if it is clear that you should not unnecessarily be there. So my request to you will be, since you know this problem, you talk to your HOD or principal and get us a mail saying that from our college there are two teams registered. This team is the final one. We will incorporate that. It is in your
All right,
interest
sir.
also. Any other point?
Sir,
No, sir.
regarding the, sir, I had one
Yes.
query, like regarding the stealth and radar cross section, etc. Regarding that, also the questions will be asked in the design competency.
If you think that a supersonic aircraft that does this mission should have stealth features, that will be one of the requirements. In fact, if you look at this particular list, it says LETs: reliability, survivability, and susceptibility. These factors improve when you have lower cross section. So definitely it's a part. Although I have not specifically mentioned that it should have a radar cross section of so much, or I have not specifically mentioned in the problem statement about the radar cross section, it is definitely a feature. If you study the literature, you will realize that aircraft with lower radar signature are definitely much better in survivability and susceptibility. So yes, the answer is it will be a part, and therefore we will definitely like to know, are you aware about stealth and how it is incorporated in a military aircraft of this type?
All right, sir. Thank you.
Okay, I think on that note, we will stop the meeting. But remember, there is a WhatsApp group and there is an email address. This meeting was only meant to give you an overview. You are welcome to use that group for your queries. So I will be requesting now Pranav Gupta to stop the meeting because he is the host of the meeting. So Pranav, I'll stop sharing the screen and